In this lesson, we will be working with numbers in exponential form. In the first part of this chapter, we will apply rules of exponents to simplify expressions that contain numbers in exponential form. Let's first review the exponential form. You will have a base raised to some power. This example is read 2 to the 4th. To find the value, we would multiply 2 by itself 4 times. Let's address commonly missed problems. On the first number in exponential form, there are no parentheses. Therefore, the base is only 3, which means you only square 3. With parentheses on the second example, you would need to square both the negative and the 3. Here shows the numbers in exponential form expanded out. It is going to be very important for us to understand what represents the base. In other words, what the author intends for us to bring to that power. Here's our first rule of exponents. It's called the product rule. Since to be able to use it, the numbers in exponential form must have the same base and must be multiplied together. If this is the case, the exponents are combined by adding them and then placing over that common base. Notice how there are 2 parentheses multiplied together and that there are not exponents on the outside of the parentheses. Because of this, the parentheses can be dropped and the product rule applied. After the parentheses are dropped, we see that everything is multiplied together. Multiply the constants as usual, placing out in front, and then apply the product rule to the numbers in exponential form. As for the quotient rule, you will see the numbers divided by one another. In this case, the exponents will be subtracted. The rule is stated in 2 ways. The reason is we always need to end up with positive exponents, and you can do this if you start with the exponent that is largest. Whatever exponent you start with, numerator or denominator, that is where the factor then will end up. With the x's and the y's in the numerator and denominator, we apply the quotient rule, which means we subtract the exponents. Again, in applying the quotient rule, let's start with the largest exponent so that exponents will end up positive. With the x's, the 10 is larger than the 5, therefore after we subtract, that variable will be in the numerator. With the y's, the 9 is larger than the 4, therefore after we subtract, the variable ends up in the denominator. If the power rule is to be applied, there will be an exponent outside of parentheses. The parentheses could contain one factor, a product, or a quotient of many factors. Here we have a product raised to a power. Each factor inside the parentheses will need to be raised to that outside exponent with this rule. Exponents then get multiplied. The rule is similar to the product to a power rule. As with the other rule, all exponents get multiplied by that outside exponent. Let's expand this one out so that you can understand how this rule works. When it's expanded out, the product rule applies in the numerator and in the denominator. And you can easily see there are 3 negatives to multiply together, 3 3's in the numerator, and 3 2's in the denominator. If we are dealing with whole number exponents, we can resort to expanding out the expression. But since we will not always have whole number exponents, let's take time to understand these rules. When you simplify applying the rule, be careful with the constant factors. It helps to break the constant factors away and talk through these, in this case, cubing the numbers. In the numerator, negative 3 cubed gives you negative 27. Denominator, we get 8. As for the variable factors, again, the product to a power rule applies. Multiply all exponents by 3. Any number raised to 0 power except 0 is 1. And with these next couple of slides, we try and make sense of this 0 exponent rule. Start with any number in exponential form and divide it by itself. Any number divided by itself is 1. If you apply the quotient rule, then you're going to subtract those exponents so that they can be combined, and the exponent works out to be 0. You'll find that you end up with a value of 1, which means in the beginning it needed to represent 1. Here we are subtracting these two expressions. Find the value of the two terms and then subtract. Again, any number but 0 raised to 0 power is 1. And in the end, we get negative 24. Thank you.